Hello everyone, this is Bhavya and today I will be presenting my poster on the regenerative potentials of the different regions of the glenoid labrum. Just an introduction. Glenoid labrum is a tissue that surrounds the glenoid cavity of the shoulder joint. Its main purpose is as an extended lining to the cavity, is to provide the stability to the joint and act as a shock absorber. Due to traumatic injuries and overuse of the tissue, this tissue can get torn. However, when we looked at the clinical data, we saw some discrepancy and noticed that all the regions of the tissue, that are the anterior, posterior, inferior, and superior, do not heal in the same manner. So this made us curious as to where is this discrepancy coming from? To investigate on that, we looked into the various compositions of the tissue, such as the vascularity, cell compositions, and the ECM density. And we tried to find the histological evidences that can support the differences we saw in the clinical data. What we did was we took the tissues explanted from the human cadavers of the whole glenoid joint. We took the labrum and we divided into 4 regions: the anterior, posterior, superior, and inferior. The collected tissues were then processed for histology, and then different staining methods were used to analyze the different compositions. The first thing we found was that there was a stark difference in the ECM compositions of the different regions, namely the superior region, that are shown to be the poorest in the regenerative potential, had the highest percentage of dense ECM area. And the inferior region, which is clinically shown to have the best outcomes after the surgical repair, had the least percentage of dense area associated with it. When we looked closer at these ECM areas, we saw was that the majority of the blood vessels were associated in the loose ECM area of the tissue, whereas in the dense ECM area, there were hardly any blood vessels. In fact, when we mapped out these vascular areas, we found that the superior region had the lowest vascular density and the inferior region had the highest vascular density. Next, what we wanted was to look into the general cellular markup, especially the progenitor cells, because those will be the main components that will be responsible for the regeneration of the new tissue after the tear. What we saw was that the majority of the cells of the glenoid labrum were around the vascular area of the tissue, and the avascular area had little to no cells associated with it. When we labeled and quantified the progenitor cells, the main cells which would be responsible for differentiating and producing new ECM for regeneration of the torn labrum, we found that the inferior region had the very high number of the progenitor cells associated with it, whereas the superior region had little to no progenitor cell density. Overall, our results were able to demonstrate the differences in the various regions of the glenoid labrum. And our results indicated that the superior region had the poorest regenerative potential due to its lack of vascularity, low cell count, and the low progenitor cell density. Whereas in the inferior region that showed the highest regenerative potential, there was very high cell density, very high count of progenitor cell density, and had the lowest ECM density. In the end, our histological data aligned with the clinical outcomes, and we were able to shed some light on the possible underlying reasons for the differences of the glenoid labrum tear regions. We believe our results will be very helpful for future scientists to come up with different regenerative solutions for glenoid labrum tears. By addressing the differences of vascularity, progenitor cell count, and ECM density, they will be able to find solutions that can work for specific regions of the glenoid labrum. Thank you.